For this video, we're finding the infinite series for e to the x plus e to the negative x, all divided by 2. So I'm going to start by writing out the series for e to the x. So e to the x is always positive, neither even nor odd, so it has every term. So 1 plus x to the first over 1 factorial plus x squared over 2 factorial plus x to the third over 3 factorial. And I'm going to write out a few more terms. So then if I want to know what e to the negative x, I'm going to substitute in a negative x for every x. So e to the negative x equals 1, and then this will be a negative x. Negative x squared is a positive x squared over 2 factorial. Negative x to the third is a negative x cubed over 3 factorial. Negative x to the fourth is a positive x to the fourth over 4 factorial, and it keeps going. So what h of x is asking us to do is add these two together, and then I'm going to divide by 2 at the end. So I'm going to draw a line underneath these and add them term by term so I have like terms vertically aligned. So 1 plus 1 is 2. X plus a negative x is actually 0, so this term cancels out. X squared over 2 factorial plus x squared over 2 factorial is 2x squared over 2 factorial. The odd powers cancel out again. I'm doubling the even powers, so this will be plus 2x to the fourth over 4 factorial. And generally I need the first 4 terms, so I actually need to keep going on this, but I know what's going to happen with the pattern. The x to the fifths are going to cancel out, and I should have 2x to the sixth over 6 factorial plus, and go out for a while. So this is actually just e to the x plus e to the negative x. But what I want is it divided by 2. So when I divide by 2, I'm going to divide each term by 2. So my h of x will equal 1. 2 divided by 2 is 1. And then these 2's are all going to cancel out in the numerator. So plus x squared over 2 factorial plus x to the fourth over 4 factorial plus x to the sixth over 6 factorial plus, put my ellipses on, and I have to figure out what this is the sum of. If I look at it now, it looks just like the cosine series, except that it's not alternating. So I'm going to write the cosine series without the negative 1. So this is x to the 2n with the 2n in parentheses factorial, and I have my h of x.